Hi there, welcome back. Let's focus, yeah, thank you. Today we're going to do our second Arduino project. It's going to be revolving around the LDR sensor, and I got it set up right here. But instead of me showing you on camera, because I don't have the option to do a good camera setup to be able to show you what I'm doing, I'm going to be drawing schematics on screen, and it's not going to be a circuit diagram, it's just going to be good old schematics, tomato, on screen using some software. And let's head right into it because I'm prepared today, so let's go ahead. There we go. So this is 123dcircuits.io. It's made from Autodesk, you know, the guys that makes 3D rendering software as well, AutoCAD, things like that. Inventor is also by them. They also make this software, and it's very cool. I have prepared my project so you can see it, and let's go over how it works. First of all, I've used a breadboard alongside my Arduino. The breadboard is hooked up in a manner, you can see the one I have in real life is exactly like the one I got on the screen. The black and the red wires at the bottom and the top are hooked up horizontal, meaning they are all connected. The ones in the middle are hooked up vertical, except they are divided over the middle. The items I have been using in this project are two resistors. You can see we got a 10K resistor there and a 4.6 resistor there. Excuse me. You may think, how do I know what type of resistors to do? Well, I know because I have done similar projects many times and I did not do any calculations. I just knew when I'm working with the LDR sensor, a 4.6K resistor is a very good choice, and I didn't have a 4.7, and that was the one I just had on my disk, so I used it. The 10K down here, that's actually fine for a button. Didn't know what to use because I didn't have anything. I didn't do any calculations, but from my experience, I know a 10K resistor is excellent for this project. I also used a button, and of course the LDR sensor itself. So the LDR sensor is hooked up with 5 volts on the left leg. You can see it's the red line down here. It goes into a resistor and up into ground. Between the sensor and the resistor, I have hooked it up to A0 using this yellow wire right there. That means we are able to detect any current running through between the sensor and the resistor. And that's the idea. We want to measure the difference from the 5 volts into the sensor and what comes out, right? The button, on the other hand, button, yeah, I know I misspelled in the other video, but hey, it's not grammar, it's electronics. The red one, 5 volts from the Arduino, goes into the bottom right. My 10K resistor goes into the bottom left, and remember, these are just parallel, they are not touching unless you press the button. The top left I have hooked up to the Arduino on port 2. That's digital. Yeah, digital port 2. And the one down here with my sensor is analog port 0. The reason I chose analog is because I want to measure a very precise value. And the reason I chose digital for the button is because I just want to know, is it on or is it not on? On or off, right? So, let's jump right into the code. Yeah, there we go. I got a blank Arduino project right here. Let's just hit new, so we are all on the same page. Full screen. Thank you. Let's remove the comments. We're not going to be needing those. And during the programming, I will of course explain some of the connections and why they are like that. But first of all, I would like my Arduino to know I got a sensor. So I let it know, and the sensor is a LDR, so I name it LDR, and it's hooked up to analog 0. I also have a button. Let's do this BTN, short for button. It's hooked up to digital port 2. That's it. That's the preparation we need to tell the Arduino before we can start working with it. So first of all, we need to let the Arduino know that each of these ports are putting things into the Arduino. So, and we do that by using the function called pin mode. I think we talked about it last time as well. Button input and the same for the LDR sensor. LDR input. This allows the Arduino to read from the ports instead of outputting data, and if you don't do this, it won't work. You need to open the ports in one direction. If you want to open the ports for multiplexing both input and output, you need to use another piece of software because the Arduino sketching software is locked in that matter. But it is possible, just not when using this. Then I want to read the value on the Arduino and I want to put it onto my computer screen. And the way we do that is by opening a serial connection between the Arduino and my PC. So we write serial begin, which means talk with the PC or send data if you want. Just talk, communicate, because it goes both ways. And then we want to set a speed, and we're just going to use 9600, which is very common. You can use all sorts of speeds, but for our purpose, this is more than fine. We are finished with the setup loop. We move down to our main loop, or loop as it's called right here. What do we want to do? I want to read the value of the sensor on my screen. We do that by typing print line value. Okay. Then we replace the value with a command to the Arduino. So the command is Arduino, what's the value on analog pin A0? We do that by typing analog read and then LDR, because if you remember, LDR means A0. That's it. Now the Arduino will print the values on my screen. Okay, before we test this out, let's just make a pause, a delay. The delay is in milliseconds, so 100 milliseconds should give us a reasonable delay. I'm making sure it's the correct Arduino and it's on the correct port. Yes, and then I hit upload. Oh, there's an error. Error status. Let's see what's the error. Yeah. Oh, it's so obvious. Well, the problem is I told the Arduino to print a line, but I didn't tell it where to print the line. Where do you want me to show this value? Okay, well, I want you to show it on the serial connection, so we forgot about writing serial dot first. Let's try that again. You can see now it says serial delay. Oh, delay. There we go. Serial.println analog read means analog read and put it on a line in the serial connection. Okay, done. It seems about right, and it says done. How do we read the value on my screen? Well, up top right there is sort of this little zoom glass right here. Click it, and there you go. That's the values. You can see it changes when I move my hand over it. If I move it up near the camera, you can see the value increases. It might be hard. That's because I got some light back there. If I leave it right here, try to keep it steady, and I turn on another light, instant change, right? And if I put my big fingers, sausages over it, you can see it drops down to 150 or something like that. It's very hard for me to make it completely light proof. You can see if I do this around 20, I think that's around the lowest it can go. It might be able to go lower, but hey, there we go. Now it's set up. So what about the button, you ask? Well, for some projects you might consider using a time constant instead of a button. because what I want to do is introduce a larger delay without actually delaying this, or maybe sending the Arduino a command. So whenever I send a short pulse to my Arduino, update the signal. That's why I use a button, so I can always replace the button with a wire from something else that sends a short burst, short small current. For example, I got this project running. This is a similar project. You can see it says Arduino sensor with the ESP. That's just me experimenting with some Wi-Fi. Anyway, I'm uploading the data to a web server, but I'm introducing a large delay, because if I didn't use this large delay, I would end up with a huge database and a huge amount of numbers that I need to filtrate in some way or do something with, because most of it would be unusable anyway. So that's why we use the button. So let's introduce the button to our code. And remember, we connected the button to ground through the resistor and through port 2. So everything on the Arduino from port 2 is connected to ground. So right now it's low, right? So we want the Arduino to say this: if the button is high, the button, well, how do we check the button? Well, we read it, and it's on a digital pin, so digital read button. So now this represents our button's value. If the button's value equals, double equals, we have to do this for Boolean values, is high, then we can upload our code. So I put a curly bracket at the begin and at the end, meaning if I upload this code to my Arduino, only when the button value is high, meaning when I press the button, it should show it on the screen. Upload. Let's try. Give it a few seconds. Thank you, it says. Okay, let's open. The screen is blank. Well, that's perfect. When I click the button, I get a value. If I click once, I get one value. If I hold it, it's running just like before. Perfect. That's it. That's how simple a advanced sensor can be used. This is something we can use in a further project, but now we know how to use the button. We know how to use our LDR sensor. That's the basics of it. And now I feel we're confident enough to, not the next video, but very soon we're going to be working with small pumps. And I got some Lego engines as well. So we're going to experiment a bit by hooking these units up to the Arduino. But before we can do our Arduino project number 3, we need to know a bit about the motors, how they work and what's going on with them. Thanks for watching. Comment, rate, subscribe, and I'll see you next time. Bye.